Most joints of vertebrates are relatively flat and can be considered as planes. Most joints are near vertical, at least during part of their function. Joints are close to frictionless with a coefficient of friction of 0.005. Let's do the math. F is the frictional force that keeps the mass from sliding down the slope. But if the joint is frictionless, we have a problem. There will be nothing to keep the mass from sliding down the slope. Let's take it to the next level. Here are the forces acting on a mass on a frictionless inclined plane. Small a is acceleration and a small g is the force of gravity. The force pushing the mass down the slope is equal to the mass times the force of gravity times the sine of the angle A. From Newton's second law, we get F equals ma, which gives us acceleration equals gravity times the sine of A. As the angle A becomes vertical, the sine of 90 degrees equals 1, and A equals G. One more time. Let's look at the joint reaction force, N. N equals mass times gravity times cosine A. As the joint becomes vertical, the cosine of 90 degrees is 0, and the joint reaction force is therefore 0, which means there is no compressive load across the joint. Under these circumstances, the only forces compressing the joint would be muscles crossing the joint at right angles to the surface of the joint. These can never be great enough to create a frictional force F that would counteract the force of gravity. The bones would then slide past one another like a clown slipping on a banana peel.